For this lesson, our focus standard continues to be from Grade 8, Expressions and Equations, Standard C, Analyze and Solve Linear Equations. The topic for this lesson is from our Simplifying and Solving Equations, Special Cases, Simplifying and Comparing Expressions. Our essential question for this video lesson is, can all algebraic expressions be compared? So today we're going to look at some special cases as we continue to practice simplifying and comparing expressions. And so please take a moment, pausing the video if you need to copy down the header. Be sure to include today's date, sub the question column, and the note column, and resume the video when you're ready to begin. So for today's lesson, we're going to go ahead and jump right into it. In our first example, we're going to compare the expression 7x minus 3 and negative times the quantity negative 2x plus 6, close parentheses, plus 3x. So we're still going to use algebra maths to go through this, but we're going to start to look at some special cases and asking that question, can all algebraic expressions be compared? So I've gone ahead and kind of set it up here, and actually I can go ahead and display this whole thing. And so I want you to go ahead, I've already given you the two expressions. Go ahead and see if you can write down which expression matches to which mat. So if you said that this expression on the left is 7x minus 3, I would agree, which makes this expression on the right, the one that is negative times the quantity negative 2x plus 6, close parentheses, plus 3x. So I know we've already had some extra practice on simplifying expressions, so go ahead and we're going to move to the right. Go ahead and simplify either of the expressions and write the new expressions. So if you would say that this expression on the left doesn't simplify because it's already has all the tiles in the top region and there aren't any zero pairs to remove, I would agree with you. So we're going to keep that one exactly the same, and it remains 7x minus 3. On the right, however, we have all these tiles to flip up, and so we want to show that they flip up, and on our mats it would look like this. So we had the 3x tiles, these two negatives flipped up, these 6 positives flip up, and each time they flip up they change signs. We have a few reminders of those steps, and so what is our new expression? What do we have on the right? Go ahead and record that. And I'm looking for the expression 5x, it would in its most simplified form, it's 5x minus 6. And so I originally had written it as these 3 x's plus the 2 that flipped up, but we don't really need that. I'm looking for 5x minus 6. Alright, and so now, same thing, there's no zero pairs to remove here. So we're looking for the balancing move for step number 2, right? Balancing is the official title of that step, and what we do is remove identical tiles from each side. Things that we can remove that are of equal value on the left and on the right that aren't going to necessarily change favorites of one side to the other. So what do we have in common on both sides that we could remove? And draw that in, and let's see if we agree when we compare those. So I removed everything except for 2 x's on the left. So I saw that there were 5 x's over here and 7, so I took 5 x's off of both sides. But I also saw that there were 3 negatives here and 3 negatives here, so I went ahead and removed those. So at its most simplified form, we end up with 2x and minus on the left and minus 3 on the right, and we want to compare and see which is greater. And we have these expressions here. But can we really compare? Can we say that this side is greater than this side? I would say no, and I challenge you to figure out why not. Why can we not say which side is greater if it simplifies to 2x minus 3? Well, the answer to that question lies in that these are variable tiles. This is a variable right here. Variable by definition is an unknown value, so we don't know what the value of x is, and it really does depend, right? It depends on the value of x. So we still don't know 2x compared to negative 3. We don't know which is greater because we don't know what this value of x is. So I'm going to lead you through an exercise today to go ahead and to talk about inequalities and to reintroduce inequalities again, and we're going to use a function table to do that. So let's go ahead and go table setup. So we've talked a little bit about functions and function machines or input-output tables in our last unit. And so I've set one up here. We typically have used 3 columns. I've added an extra column in a big black line to say, well, this is really something extra. So I've given us an input column and some values that I think will be helpful for us to test. So in sequential order, -4 down to +4. The rule is coming from the expression on the left. That's the one that up here simplified to being 2x, has the variable in it. We have a value here, so we're going to plug these different values in and say, well, what if x was -4? What if x was -3? And we're going to plug them in and see what the output is. And then we're going to compare that to the value on the right to see how it compares to -3. So I'm going to ask you to pause the video here, set up your table, pause the video and see if you can fill this in, and then we'll talk about what these values mean that we get. And then go ahead and resume the video when you're ready to compare your work. So remember, as we plug values in, we want to use parentheses to show that we're substituting. And so I'm sorry, this is in the way. So we're using parentheses to say we're taking the function 2 times x and we're going to plug values into it, and then what is the output that we get? If I take 2 times -4, I get -8. And now how does -8, if x was -4, we know that we would get -8. How does that compare to -3? Well, -8 is less than -3. Keep going, we're going to do some. So I'm going to go to here, show substituting in these 2 values. So if we put -3 in for x, we get -6 as an output, and -6 is less than -3. We put -2 in, we get -4, and -4 is less than -3. So what happens here when we put -1 in? Substitute that in. If we put -1 times 2, we get -2. Well, now -2 is greater than -3. So right here between these two, I'm going to highlight that yellow, it switches. Actually, let's highlight these different colors and we'll see. We'll end up, don't just highlight it yet, but right here we see a switch. It went from the expression on the left, if we put in -4, -3, or -2, the expression on the left would be less than. But now as we put -1 in, we get a value that's actually greater than the expression on the right, -3. And if we take a look at the rest of these, and we substitute these values in, everything we get here from -2 on is going to give us a value that's greater than -3. So it really does depend. So these ones are all the same, so I'll leave those yellow. But here, they all ended up being greater than with these x values. So it really was the difference between -2 for x and -1 where it switched over which expression was greater. So we need to write a summary sentence for that. Therefore, if x is less than or equal to -2, then the expression on the left is less than -3. But if x is greater than or equal to, greater than or equal to -1, then the expression on the left is greater than -3. So that answers our question up here. Which is greater, the left or the right? 2x or -3? And we said, well, it depends. If x is less than or equal to -2, the expression on the left will be less than. And if x is equal to or greater than -1, the expression on the left is greater. So that wraps up our video here, but I'm going to leave you with one more challenge question. Is there a value for x? So we used a table of integers here. Is there a value for x that would make the two expressions equal? And what might that value be? So go ahead and think about that as you make sure that your notes are complete and come ready to discuss that more in class.